Hey guys, this video is 9.2. It's about the quadratic formula. And basically what the quadratic formula is given a general quadratic, ax squared plus bx plus c. If we solve this for x, we'd have to complete the square, and it takes about half a page. We would end up with x equals this, and these are the coefficients, the a, the b, and the c. And pretty much we just plug them in here and try to grind out the math and not make errors. Easier said than done on some of them. Quadratic formula will solve any quadratic. That said, it's not always the best tool for the job. So if something factors, that's definitely easier than either completing square or quadratic formula. If a is 1 and b is even, so if the first term is just a plain x squared and b has the x term has an even coefficient, it will be easier math if you complete the square. And then if either of those two things fail, so if a isn't 1 or b is odd, then go with the quadratic formula. And you don't have to follow those rules, but it's, and they're not even rules, they're just suggestions. But I found that that's what will get you the easiest math, given if you're equally good at all three methods of solving. So this first one, no matter what it's going to turn out, we don't want to do the fractions. So the first thing we're going to do is multiply both sides by the LCD, which in this case is 30. So do 30, and you think of it as 30 over 1 if that's helpful. And that's going to cancel this one and make this plain x squared. 30 over 15 would be a minus 2x, and 30 over 2 would leave minus 15. 30 times 0, careful, that's still 0. And if there's anything that multiplies to negative 15, it has to be negative 2. That's the way to go. And there is. So I can just do x, and then minus 5 and plus 3. So that's the factoring, and we always want to check for that first. And if it does factor, then it's pretty friendly. So this one, let me write it a little bit bigger over here. This one really throws people. It's just a GCF, and I put it on there just to remind you of how to do the easy ones. So this is 12x would be our GCF, and it's going to leave an x and a minus 2 equals 0. So for this one, it's just x equals 0, because if I had 12x equals 0 and I divide the 12 over, I get x equals 0. And that's going to be the case anytime there's an x out front. The 12 really doesn't do anything. It's the x that counts. And then x minus 2, so then x equals 2 would be a solution. Okay, so this next one, there isn't anything that multiplies to negative 6 and adds to be 10. So this is a good place for either the quadratic formula or completing the square. In this case, a is 1 and b is even, so I'm going to use completing the square. And I will do one in a couple of examples where I do it both ways and try to show you why the completing the square isn't actually terrible. Sometimes it makes easier math. So for this, we're going back to 9.1, and we're going to bring the 6 over, so adding the 6. And then here, half of 10 would be 5, and squared would make 25. So we'll do plus 25 on both sides. And then this is going to factor to x minus 5, quantity squared. And this is going to be 6 and 25 for 31. And then we can root both sides of that. And we need that plus minus. So that's going to be x minus 5 equals plus or minus root 31. And then just kick the 5 over. And then a reminder, when you have this kind of answer and you're putting it in the computer, remember it goes 5 plus root 31 in the first box, and 5 minus root 31 in the second box, because those are two distinct solutions. So this one, a is not 1 and b is not even, and 2 times 8 would be 16, and there's nothing multiplies to be 16, adds to be 7. So that pretty much exhausts factoring and completing the square. So this is where we'd want to do the quadratic formula. And here, a equals the 2, b equals the 7, and c equals 8. And I'm going to go ahead and write out the quadratic here just so you can see what I'm plugging into. And on my test I give this. If you have a different instructor, you want to check that out. They may make you memorize it. So plugging in, I'm going to get x equals, b is 7, so it becomes negative 7 plus or minus 7 squared minus 4 times a times c all over 2a, so 2 times 2. And then we just have to clean this up. So x equals negative 7 plus or minus 49 minus, that'd be 8 times 8, 64 over 4. 49 minus 64 would be negative 15. And then when we have a negative like that under the radical, then we need to write it with using I. So that's going to be negative 7 plus or minus I root 15 over 4. So for number 5, it's not quite in the right form, so I have to do a little bit of work to get it there. I'll just bring this side down, and we're going to FOIL this out. So we're going to have x times x for x squared. On the outside we get minus 2, on the inside we get minus 4, so it's going to be minus 6. For the sake of space here, I'll just do that together in one step, and plus 8. And then from here I want to bring over the 8x and the 11 and get it to 0. So minus 8x plus 11 minus 8x plus 11. And I think I'm going to write the 0 on this side just because, I don't know, I'm used to the 0 being on the right. So these would cancel, and then I'm going to have x squared minus 14x plus 19 equals 0. So from there, according to what I said earlier, we should complete the square. So let me show that version. So it's going to do, we're going to bring the 19 over. And then I'll do half of 14 would be 7, and then squared would make 49. So I'll add 49 on both sides. And this factors to x minus 7. And this side would be 30. And then I can root both sides on that. Do a plus minus. So x minus 7 equals plus or minus root 30. And then here the 7 comes over. And then that is it. 30 is 5 times 6, and 6 is 2 times 3, so there's no perfect squares in there. So that would be our solution. Picking it up from here, I'll do a equals 1, b equals negative 14, and c equals 19. And so then plugging all that in the quadratic formula, I'm going to get x equals, remember it's negative b, so this will be negative 14 or positive 14. And then plus or minus negative 14 quantity squared minus 4 times a times c. That's all over 2a, so 2 times 1. So x equals plus or minus 14 plus or minus negative 14, and that's quantity squared, so this is always going to be a positive number. So careful not just type in negative 14 squared on your calculator, because it'll tell you it's negative 196, and it's really negative 14 times negative 14, so positive 196. And 4 times 19 is going to be minus 76, and over 2. And that's going to leave me 120 under the radical over 2. And then 120 I got to simplify a little bit, so that is 4 times 30 under the root. So I'm going to bring out a 2. Root 30 stays in over 2. And so this piece kind of adds a little level of difficulty. And then the other thing is that if it simplifies right here, here, and here, if there's something that goes into all 3 of those, then I need to reduce. I like to think it was just knocking a 2 out of everything. The reason you can do that is because I can actually factor a 2 out of the numerator. And then that allows me to cancel. But again, when I'm doing it, I just kind of think So 2 goes into 14 7 times, 2 goes into 2 once, and 2 goes into 2 once, so I wouldn't put it over 1. But because I can factor, I am allowed to cancel, and I do need to reduce. So it's kind of those last two steps, the simplifying the radical and then the reducing, that tend to get people. And that's where, remember, this one started right here, basically. This was a lot less work, and it was a lot easier math. So when the quadratic formula is, when completing the squares available, i.e. a is 1 and b is even, this is easier. This is terrible if this is odd, because then you can get fractions all the way down, and that's where this one's going to be better. So for number 6, we have to remember our cubed formula, and this one is a cubed minus b cubed. So that's going to be a minus b, a squared plus ab plus b squared. And so we'll factor this first. We can get 1 0 here, and then we're going to have to use the quadratic over on this piece. And then remember, if this is a plus, then this is a plus minus plus. The signs go same as what we started, opposite what we wrote, and then positive. So this one's going to factor to 2x minus 1. And then I just do a times a, and goes here, 2x times 2x, that's 4x squared. A times b goes in the middle, so 2 times 1, 2x, and 1 times 1 on the end, plus 1. So for this piece, we'd have 2x minus 1 equals 0, so 2x equals 1, and then x equals 1/2. So there's my one real solution. And I'll take this piece and toss it in the quadratic. So that's going to be x equals -2 plus or minus 2 squared minus 4 times a is also 4 times c is 1 over 2 times 4, so 2a. And then I got a bit of cleaning up to do here, so -2 plus or minus 4 minus 16 over 8, which will be x equals -2 plus or minus -12 over 8. 12 is 4 times 3, so I'm going to bring out a 2. So x equals -2 plus or minus 2, and there's a negative, so we'll do an I. And then that 3 stays behind, because we're like that, over 8. And then lastly, I can knock out just the 2's everywhere. So this will be -1 plus or minus I root 3 over 4. There's an invisible one right there. This next one has a GCF of x squared. So when you get that out of the way, that leaves me 2x squared minus 5x plus 4 equals 0. So this one gives me what's called a repeated root, where it has multiplicity 2, so the 0 would be x equals 0 for the one out front, and it counts as 2 answers because of the squared. Here I'm going to do quadratic formula, and that's going to give me my other 2 answers, which we'd expect because this is to the 4th. Likewise to the 3rd, I got 1, 2, 3 answers there. So tossing this in the quadratic, I'm going to get x equals negative of -5, so that would be a positive 5, plus or minus -5 squared minus 4, a is 2 and c is 4, all over 2a, which is 2 times 2. And then cleaning this up a bit, I got x equals 5 plus or minus 25, 8 times 4 would be 32 over 4. X equals 5 plus or minus, that would be a -7 over 4. And then just writing that with the I notation, x equals 5 plus or minus I root 7 over 4. And then that would be my other 2 answers, because this one was to the 4th. Okay, so these last 4 I would have you guys try. So fractions, we're going to clear them. We're going to multiply everything by 4. And so then the 4's cancel, leaving 3x squared. 4's cancel, leaving minus 2x. And here they leave a plus 3 equals 0. And that, there's nothing multiplies to be 9, adds to be negative 2, so I'll do quadratic formula. So x equals the negative of negative 2 is what I kind of keep saying, which will make a positive 2 on the next line. And then negative 2 squared minus 4 times a times c, all over 2 times 3, 2a. So x equals 2 plus or minus 4. 9 times 4, that's 36 over 6. So x equals 2 plus or minus, this is negative 32 over 6. And that right there is a 16, or you think of it as negative if you like, 16 times 2. So 4i is going to come out. So x equals 2 plus or minus 4i root 2 over 6. And that can knock a 2 out of everywhere. So 1 plus or minus 2i root 2 over 3. Number 9, this is one where we have to do a little FOIL to get it there. So x times x is x squared. On the outside you get minus 8x. On the inside I get minus 3x. And on the end I get plus 24 equals 1. X squared minus 11x plus 24 equals 1. Take a 1 off both sides, just kind of get it to 0. So x squared minus 11x plus 23 equals 0. And 11's odd, so I would go with quadratic. So x equals 11 plus or minus negative 11 squared minus 4. A is 1, C is 23, all over 2 times 1. So x equals 11 plus or minus, this would be 121 minus 4 times 23 is 92 over 2. And then x equals 11 plus or minus, that comes out to 29 over 2. And that's as far as we can take that one. Okay, so number 10 just has a little GCF of x, so I'll get that out of the way first. So x squared minus 4x plus 10 equals 0. So this one's going to be x equals 0. And then for this one, I would complete the square because a is 1 and b is even. So I'm just going to bring the 10 over. And then I can do half of 4 will be 2, and then squared will make 4. So plus 4 plus 4. Factoring this side, I have x minus 2 squared equals negative 6. And then I can do the square root on both sides to undo the square. And then that's going to go x minus 2 equals plus or minus I root 6. We'll take care of the negative. And then just bring the 2 over. So x equals 2 plus or minus I root 6. And then this last one's a cube. So we'll factor it first. So it's going to go x plus 3, x times x for x squared, x times 3 for 3x, and that'll be a minus, and then 3 times 3 for 9. So this one gives us, that's x equals negative 3. So there's our first answer. And I'll toss this one in the quadratic because that's odd. So x equals negative 3, or 3, plus or minus negative 3 squared minus 4 times a times c, and that's all over 2a, and a is 1. So that's going to go x equals 3 plus or minus 9 minus 36 over 2. That's going to be 3 plus or minus negative 27 over 2. Negative 27, that's a negative 9 times a 3. And so I will have 3 plus or minus, the 9 comes out as a 3, and then the negative comes out as I, root 3 over 2. and that doesn't go in, so that would be it.